Let's explore HTML Web Workers, a powerful tool for running scripts in the background and improving the performance of your web applications. Web workers are JavaScript scripts that run in the background, independently from the main browser thread. This means they can execute CPU-intensive tasks without blocking the user interface. Web workers communicate with the main thread by sending and receiving messages. You can use the post message method to send the messages and onMessage event to receive the messages. There are several reasons to use web workers. First, performance. You can run CPU-intensive tasks without freezing the user interface, keeping your app responsive even during complex operations. Second, multithreading. You can leverage multi-core processors by running code in parallel, distributing workload across multiple threads for better efficiency. Third, isolation. Workers run in an isolated thread with their own memory space. This means that the errors in workers will not crash your main application thread. While web workers are incredibly useful, they do have limitations. The first limitation is no direct access to the document object model. Workers cannot directly access or manipulate the document object model, window object, or parent objects. Second, limited access. Workers cannot use some methods and properties available in the main thread, like alert or confirm. Third, communication overhead. Data is copied between threads, not shared, which can impact performance with large data sets. Fourth, resource-intensive. Each worker creates a new thread, consuming additional system resources and memory. To create a web worker, first create a separate JavaScript file for your worker code. Then instantiate a new worker object with the file path. Use the postMessage method to send the data to the worker. Set up the onMessage event handler to receive data from the worker. You can optionally handle errors with onErrorEvent handler. Inside the worker script, listen for messages from the main thread using the onMessage event handler. Extract the data sent from the main thread. Process the data as needed, performing the required operations. Send the result back to the main thread using the postMessage method. It's important to note that workers have their own global scope and do not share memory with the main thread. All data is copied between threads, not shared. Let's look at a practical example, calculating prime numbers using web workers. In the main script, which is typically in your HTML file, first get the references to the HTML elements. Add a click event listener to the Calculate button. Inside the event listener, create a new web worker, passing the prime-worker.js file path. Use worker.postMessage to send a maximum number to the web worker. The web worker finds all the prime numbers up to the maximum number passed to it. And finally, set the onMessage event listener function to receive the primes array from the web worker. Inside the web worker script, first get the maximum number from the main thread by listening to the onMessage event. Call the findPrimes method by passing the maximum number. Implement the findPrimes method to find all the prime numbers. The isPrime method checks if a number is prime or not. And finally, use the self.postMessage to send the array of primes back to the main thread. There are times when you might need to terminate web workers. You can terminate a web worker from the main thread by calling the worker.terminate method. This immediately stops the worker without completing the current tasks. You can also terminate a web worker from within the worker itself by calling the self.close method. This is useful for self-termination after a task completion. It's important to note that once terminated, a worker cannot be restarted. You must create a new worker instance if you need the functionality again. It's important to handle errors properly when working with web workers. You can handle the errors from the worker in the main thread using worker.onErrorEvent listener. The event object provides information about the error, such as the message, the file name, and the line number. Inside the worker script, it is important to wrap the worker code in try-catch blocks and send the error information back to the main thread using self.postMessage. Some best practices include using the on or event handler, try catch blocks and structured error objects. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.